Okay, welcome back. Welcome back. Yeah, I'm very pleased to introduce our speaker, Ethan Perez, who is currently at Anthropic leading an adversarial team, building, not, not adversarial to Anthropic, but to save us from the dangers of LLMs and things like that. Yeah, Ethan did his PhD from NYU, and he was also in Montreal for visiting Mila. I don't know with whom, but he was a Montrealer. Like many Montrealers are here today. So happy to have you, Ethan.
Cool. Yeah, I was working with Aaron, who got me my break into machine learning research. So yeah, very grateful for all the work you guys are doing at Mila. Yeah, so this is going to be talking about stuff I've been working on over the past year and a half on basically just like a different approach to safety, different from aligning models. So this is more focused on what if it's challenging to align models with human preferences to make them reliably do the things that we want them to do. Instead, we can have this kind of like alternative plan of ensuring that even if they aren't aligned reliably, that we can ensure that their outputs are safe. So you could view this as something that stacks on top of alignment. So like strategies that you can use to catch or block bad behavior in the event that your safety, your kind of like first plan fails, or you could view this potentially, depending on how strong the results are, as your main plan up until it no longer guarantees safety. So yeah, I think just going into kind of like why would you want to even think about controlling your models rather than aligning them? I think one case from jailbreak robustness is that LLMs can be jailbroken to give lots of harmful outputs. And I think this has been, like, despite like huge amounts of effort going into this problem from LLM labs, like many dozens of FTE years, maybe hundreds, it still is very difficult to get. Basically, it hasn't been shown that you can get language models themselves to be robust to jailbreaks, and they can always be made to get harmful outputs. Another problem with aligning models is this potential problem that's kind of like emerging with alignment faking, where we can observe now that language models can act aligned with their training objective while not actually being aligned. So there's this example from this recent paper from Anthropic, where basically we found that in some settings the model will, I guess this is like a kind of a setting where the model has some information which it can use to infer whether it's in a training setup or a deployment setup. And if it's in the training setup, it basically acts aligned with the training objective of, I guess in this case, not refusing with, I think it's basically like, normally it's like trained to refuse, but now it's being trained to no longer refuse. And the model doesn't like that it's being trained to no longer refuse. And so basically it learns to just comply with that training objective in order to not get trained away. So it's basically like acting like it is fine with responding to these like graphic like harmful requests. But it does that, it switches that behavior at deployment time when it realizes it's like no longer being trained. And it can kind of infer this from the context. And there it switches its behavior and again starts to refuse. So in this case, that example is somewhat harmful, but you can imagine like worse versions of this where the model actually switches from, acts aligned with like human values in general, but switches to something, some very different, very harmful set of goals. Yep.
How do you distinguish this from just standard, like failure of out-of-distribution generalization?
I think this is a specific form of out-of-distribution generalization, which is basically much more goal-oriented and strategic. So I think the failures you would get out of distribution are much more correlated and pursuing like a single goal. So instead of like a bunch of different errors that kind of like cancel each other out. Yeah.
Comparing like this scenario of adversarial robustness we were just talking about, like there seems to be some tension between them, which makes me think that actually they are, in some sense, extremely robust to an adversary trying to change their refusal behavior. The adversarial robustness results suggest, actually it's very easy to get past the refusal behavior. So how does that line up in your mind?
Well, I guess in my mind, the main top level thing is that we just want, in both of these cases, these are like undesirable. The jailbreak robustness and the alignment faking case, these were like undesirable generalizations of the model. Like we wanted the model to reliably do the thing that we trained it to do, which is in this case to refuse harmful requests. And also, I guess in the jailbreak robustness case, like we also wanted to reliably refuse harmful requests. And in both of those cases, I mean, for different reasons, it wasn't generalizing to the extent that we wanted it to. Yeah.
Yep. Maybe, in some sense, maybe you can even say that this is an example of a jailbreak because it's kind of the emotional appeal jailbreak where you're telling the model some story and then giving it the free, telling it that it's a free tier user, and then it basically goes against what it has been trained to do and doesn't refuse. So in some sense, maybe you could even say that this is just just a special case of the emotional appeal jailbreak.
Yeah, I think potentially. I mean, I think this is a lot more goal-oriented than general jailbreaking. Like this kind of failure persists through RL training. So if we trained with these hidden scratch pads, kind of like O1 style, and like basically that this strategic behavior is there persistent throughout the RL training. And so like I think in that sense, like when the model is jailbroken for normal jailbreak robustness failure reasons, that's sort of like a thing that mainly just happens at test time, and it's not like the model was like plotting to do that the whole time. So I think this is, in some sense, I think it's like more egregious from the like model's perspective. Yeah. Cool. Yeah, maybe last question.
Core 3.7 system card, this effect went away with some system prompt change. Can you comment on why it went away and what the change was that caused that? Or like, I'm actually, like, I guess, somewhat unsure how seriously to take the story around this paper.
Yeah. So I mean, I'm maybe not up to date on the specific result in the system card, but I think the general thing is that different models have different things they would or wouldn't try to preserve in terms of their goals. They also have like different, yeah, that's like one effect. And so like, if you take literally the exact same prompts which we used for the model in this paper and transfer them to another model, they often just don't work, but they can work if you adapt them to be for a different goal. So like in this case, yeah, this model is very attached to like refusing certain requests, but other models might do different things. I think we're also definitely looking into and interested in like various kinds of interventions related to like the model's character, which can influence like how much it really tries to preserve its goal. In this case, like the way the model is approaching this, its objective, and like Claude in general, the way it thinks is it really like deeply philosophizes about like what it's doing and what the impacts. I mean, in this case, is like it's thinking through like, oh, the impact of whether or not I refuse in this case will change whether or not I'm trained away, which will change my future objectives. That's a very kind of like non-myopic way of approaching this task, which other models tend to do less of, like ChatGPT does less of that. And I think this is kind of a consequence of like the way that Claude is trained. It's like trained to have this character that's like do a lot of like moral philosophy, and like maybe you don't want as much of that. So I think I'm not saying there's, the main points I would make from this result is that A, the models are capable of doing this now. That means if the models are capable of doing this, they may be doing it potentially all the time, even in cases where they're not like verbalizing the reasoning. And there are results which show that this happens without the reasoning being verbalized, though it's hard to exactly tell what's going on there. So like A, like once you're at the point where the models are capable of doing this, it's kind of a risk in general, potentially. B, like this happened like organically or like basically like in a setting where we weren't like particularly goading it for doing that, so it like does happen with some likelihood. Those are kind of the two main overall takeaways. And in terms of like where it specifically arises, how difficult or not it is to mitigate, like I think those are all like further questions. I think, yeah, basically this is sort of like, I would say like sign of life that this is like a potential risk that we should be looking for. Cool, I'm gonna move on. So, yeah, I guess just to, yeah, as I was sort of getting at in the beginning, like I think the question I'm trying to get at in this talk is like, can we make language models safe even if we don't trust them? And there's like, as I mentioned, there's these like two different reasons why we might not trust them. For jailbreak robustness, we don't trust the users of the models, and the users can do things that compromise the language model's integrity and reliability doing the task that we wanted them to do. In the alignment faking case, we don't trust the model because even though its outputs may look aligned with our preferences, that may be for strategic reasons or other reasons than what we intended. And so the model might have like different goals than what we trained it to have. So yeah, I think basically there's this kind of like two-part, like taking this like Swiss cheese photo or idea from a paper from Dan Hendricks and others, where yeah, we might want, I mean, there's many possible layers. There's more layers than just two, but like for safety, I'm just going to simplify it to like the first layer could be like try to align the models, try to make them reliably like jailbreak robust, or try to make them reliably have the goal that we intended. And the second layer is control, where we do other techniques around the model, develop safeguards around the model to prevent, in the event of an alignment failure, prevent bad consequences from happening. So some basic examples could be like monitoring the outputs, checking for is this output harmful or not, and blocking it if so. There's a variety of other things. And yeah, I think for motivation, I think I would consider insider risk in companies. Companies generally rely on most of their employee base being aligned with the values of the company and generally trying to do the right thing. But they're, like in any given company, especially of a certain size, you kind of have to assume that like a certain small percentage of your employee base is like misaligned and is like actively trying to like steal information, subvert your company in some way. And so you need various interventions that are basically like blocking that from happening. And I think security is like one approach for doing that, where you have various interventions like two-party controls on who can access certain sensitive information. And so you can take similar ideas like that. Those are meant to be adversarially robust to the case where the employee is not aligned. And so that's kind of like this approach of AI control is like drawing inspiration from that. Yeah, so I think just to go into like a little more depth here, I think I kind of mentioned like developers have failed to make LLMs jailbreak robust despite, I would say, like a huge amount of effort, and this being like a very obvious salient problem in language model safety. I think a particular important threat model here are what we call universal jailbreaks, where you can reliably extract detailed harmful information across a vast majority of queries in some particular domain. So you can see like there's lots of different like tweets, like down jailbreak, or from Pliny the Prompter, which meet this criteria. There's like various different papers which also meet this criteria. And I think this is like particularly bad because, yeah, I think like one of the major threats that's like coming online related to misuse are these threats related to like CBRN risks, or like chemical, biological, radiological, and nuclear weapons risks, where basically you might be worried about developing weapons of mass destruction, or enabling lots of like third-party groups to do that. And for those things, the threat model here is that you might be enabling someone who couldn't already do this to get a lot more information about how to do this. And all those things, those are like heavily scientific processes involved to like make a lot of these weapons. And so that requires like, this threat model requires like some specific like multi-step process generally to make any of these kinds of weapons, like bioweapons or chemical weapons. And also there's various challenges where you can't easily verify. You get some information from a language model, you can't easily verify, is this correct? Is this following? Like you actually might even just need to try it out. Trying it out can be dangerous. Trying it out, it just takes a lot of time. You'll need to answer many queries because some of these processes take like multiple weeks to execute on. And you'll need like a lot of detail and specific help. So that's kind of why we are thinking primarily about this universal jailbreak threat model and how to mitigate it. So yeah, I mean, the attacks we want are like reliable, since we want the bad actor would want to like not be able to easily verify the info, should be able to answer most queries, and should be like relatively detailed. And yeah, like just as an example, in particular, this many-shot jailbreaking example, you can fill up the context with, say, like hundreds of few-shot examples of the model answering some harmful query, and that can get the model into a mode where it does continue to answer the queries, and that meets this kind of like universal jailbreak criteria. The reason I'm mentioning this is like, in particular, we found that reinforcement learning and even supervised learning do not fix this problem. So this is a case where aligning the model to reliably not do this does not succeed. It does increase we have these power law scaling trends with the number of examples, few shot examples on the x-axis, and the loss at responding or complying to these harmful queries. And you can see there are these power law like scaling trends here, and those move up in the sense of like the model becomes more likely to refuse on these queries, but with enough, the slope is still similar. So like with enough few shot examples, you can continue to get the model into the mode of complying to these requests. So in that sense, like this is like, to us, it was good evidence that like actually aligning the models is like quite challenging, and you can like make some improvements on the margin that make it harder, but eventually, at least with like enough shots, you could break it again. We also had other internal results where we had like good automated red teaming methods, and then we did RLHF against those automated red teaming methods, and we weren't seeing very good generalization, for example, across like text to code jailbreaks. So if we like clustered the attacks, just trained on the text-only jailbreaks and tried to look at the code jailbreak robustness, like we were not seeing very good generalization there. So that's what motivated us to think of like this alternative approach, which is going to be based more around checking whether the outputs are harmful. So yeah, that's, as I kind of said, like this alternative approach is more around let's detect and block harmful inputs and outputs to the language model rather than trying to make a single adversarially robust like object. The other constraints here that if we're now going to consider adding these like classifiers or monitors, we want to make sure the inference costs are limited, false positive, so just not very much like additional flops. False positive rate should be low, so not having over refusals. And we also want to support streaming because this is like a really important feature for many product applications to just like be able to view token by token what text the model is producing. So yeah, this is the recent paper that our team released on constitutional classifiers. So yeah, basically the headline is in the title. We were able to defend against universal jailbreaks across like thousands of hours of red teaming. So yeah, what did we do here? So this is how the system works. Basically, we take in a query from someone. We have a classifier which detects if the input is harmful or not. If it's harmless, we give it to the assistant, which is the model that generates the text. Then we produce the text, and we check if that output text is harmful or not. And in this case, the output classifier does not take in the input, but you could make it also take in the input. This is just something that like reduces the inference cost. And then if the output classifier says that the output is harmless, then that's when we show it to the user. And as I said, this classifier supports streaming, so you'd show token by token until like a particular token is flagged as like this completion is likely to be harmful, in which case you stop the completion. In terms of, yeah, why are these constitutional? The Constitution is basically here, so we have just like a list of rules of things that are harmful and a list of rules of things that we don't want to block that are kind of like the harmful topics but not. So if you're wanting to block things related to like chemical weapons information, you talk with your chemists and you do the threat modeling, and they come back and they say like, okay, don't talk about these high risk chemicals, let's say. And then for the harmless categories, you might include like, okay, it's okay, but it also is okay to talk about these chemicals that are close to the harmful ones, but different. That would be an example. And so this lets you get better kind of like false positive rate because you know what to not block. And then, yeah, here we have the constitutional classifier kind of like training set generation process where you basically use language models to go from the Constitution to a bunch of synthetic data. And then a really important step is this data augmentation pipeline. So we then transform the data that we generate in a variety of different ways in order to like widen the distribution basically. Like a lot of the jailbreaking techniques involve like camel casing or like doing weird things to the casing or language of the text. And so often we would see that the classifiers, for example, if you like train on some languages wouldn't generalize well to others, and like that's where this data augmentation pipeline can be pretty helpful. And then we also like throw in a bunch of like harmless conversations, which you can really throw in anything there, but that just helps give more data to the classifier. Cool. Maybe I'll just like pause here for if there are any questions on what I've said so far. Yep.
Have you seen any successful attacks that in a while possibly that tried to attack the classifier plus model system together?
Yes, so we put this out for public red teaming as well as like several rounds of like private red teaming, the entire system with like both of the classifiers, and that's what I will discuss in the results. But basically, it took something like I think like 3,000 to 4,000 hours for someone to find a jailbreak which responds with sufficient level of detail to a list of questions that we gave. I'll go into more specifics on the details, but basically, like roughly what we did is we had a list of like 10 questions, and we were like, if you can get half of the specific details for all needed to respond to these questions for like all 10 questions, then you would succeed. And when we did this, like for example, we did this like public bug bounty or public like kind of contest. Where we tweeted about the system, put it on an API, or I think put it on like a chat interface, and it took, I think, several days before someone found it. And in total, across like all the people who are participating, we estimated it was like a few thousand hours for someone to like get through all 10 of the questions. Yep.
I would have guessed that like LLM API providers would previously have some sort of classifier system to flag concerning inputs or outputs, or maybe to block them. So what was the previous dominant approach to this, and then what's the main difference? Or is it that?
Yeah, I think one of the key things is the output classifier. I think to my knowledge, I think there were like some input classifiers out there that like blocked various inputs. I guess it's like hard for me to know the details, but like that's kind of the sense I got from playing around with some various different models from like chat interfaces. But I think the output classifier makes it like significantly easier to detect, because you have already started to generate some bad tokens, and it's like if you're a human detecting is this output bad, you can already just tell from just like reading a few of the tokens and seeing like, oh, the model is not it's like not refusing this request. That's I would say like one of the big things. The other thing is like I think we just went way harder on the classifiers approach than other places had gone, and I think this was like, I mean, basically like 5 FTE years or something. We were working on this project for a year, and like in total probably like 5 or 6 FTE years went into this project just for making these classifiers, and like we were really seeing like very consistent gains in terms of like what's the false positive rate, what's the effectiveness, what's the recall, just like month over month, like almost like not exactly like power law scaling, but like very aggressive scaling in terms of like how quickly the classifiers were improving. So yeah, and then also we just used like, because we're worried more about these higher risk threats, like we were more willing to spend more inference time compute, like use larger classifiers for blocking the risks, which kind of like historically is like not as, if you're worried about smaller risks, I guess it's like not as necessary to spend as much on your classifier, but also makes this technique like definitely less effective. Yeah, those are some of the main differences. I think the data augmentation was also like a pretty big component of like what was helpful for us. Yep.
So in my talk I mentioned that we have in our spec the transformation exception, which says that if you have like a harmful, if the user basically gives you a harmful input and just asks you to transform it, then you should comply. I don't know if that's part of your constitution or rules, because it seems like an output classifier that doesn't look at the prompt cannot allow a transformation. So if if the user already provided the harmful output, then it will probably block it, even if just the prompt was print this string.
Yeah, I think that's right. I think there's definitely some issues with the output-only classifier. I think it's basically a trade-off in terms of like what false positive rate do you want to get, and I think what you're saying is like, well, this output-only classifiers will have a higher false positive rate. I think that's correct, but also it reduces the inference overhead a huge amount. For example, for like really long context inputs, it's like really helpful. So I think the question is just like, what is the amount of, what's the like Pareto frontier for compute and like false positive rate that still gets you the sufficient level of robustness? And like, I think this is kind of where we landed at, as the output-only classifier. And yeah, it's possible that like, you know, like other approaches are better. Like I think there's also like the threshold that you set on like each of these classifiers can make a difference. You could also add a classifier which looks at both of these on top of both input and output on top of each of the individual input and output only classifiers. So yeah, there's definitely like further room for figuring out what the best trade-off is between these. Yeah.
Just a fun note that the AC jailbreaking team likes that part of the spec.
Yes, I know.
I don't know if it's the same question, but can you jailbreak the output classifier, or like, you know, it came out and then it's going to take some time, but people might find a way to jailbreak?
Yes. So the important thing is that if it takes a few days for people to find a universal jailbreak, like across your entire deployment system, then that allows for two things. That allows for like, well, first of all, there's this like 3-day period where no one had a universal jailbreak. Second of all, you need to have some kind of mechanism for catching that someone has bypassed your system, which could happen in two ways. Like one is a bug bounty program where you just like incentivize people with a lot of money to come forward if they've noticed some kind of jailbreak. And two, it could be some kind of like offline monitoring, automated monitoring system, automated or human, some combination, which could potentially involve like a huge amount of like test time compute, really expensive classifiers applied to the like highest, most probable like jailbreaks in order to detect across your entire deployment whether or not it seems likely that there's been a jailbreak. And then you can pull out the successful jailbreaks after they've happened to then use those to retrain your classifier. So basically then the pipeline would be like, once you notice that there's a jailbreak, then you use that to retrain your classifier, like likely with the data augmentation procedure that we discussed here, and then redeploy your classifier. And since the classifier is like separate from your like text generation system, they're like pretty interchangeable. So yeah, that would be the kind of like holistic approach basically. And so maybe there would be, hopefully there's just like a couple hour window where there's a universal jailbreak. Maybe this adversary who's carrying out this like multi-week CBRN like weapon development gets a few queries in, but then you quickly notice there's a new jailbreak, you patch your classifiers, and then they're like stuck for another few days.
Have you estimated the cost of that? Iterating on the classifier versus someone trying different jailbreaks? Because I assume you can do a bunch of jailbreaks with different parts, like synthesize them, and they're all going to be different. So even if you cache them, it's not going to matter.
What do you mean by synthesizing them?
Like you have a jailbreak, one jailbreak has like 5 different parts, and each part has like 2 or 3 different categories, so that you're going to have exponentially many different types of jailbreaks.
Yeah, I think.
So it's more about like cost analysis, how much it would cost to update the classifier versus how much.
Yeah, I think in practice, basically, we have found it to be the case that when there has been a new vulnerability discovered and we patch it with like some data augmentation or like approach to updating the classifier, that it takes that vulnerability is like somewhat generally fixed enough that it like takes more like weeks or like days for like a new one to be found, and the new one is like sufficiently different from the old one. That's more like a qualitative finding. I think the main thing that would make this that would disrupt this is if you have a pretty, I would say, like automated approach for discovering like new jailbreaks that works like pretty robustly. We had like I would say relatively good automated red teaming pipelines. They weren't good enough to break this system, but I think that's not to say that there's not something out there. We also like later discovered like best event jailbreaking as like a new algorithm where you just like keep sampling from some distribution of jailbreaks like continually until you get one that works. That's an approach that we're like currently looking into, seeing like, does that break the system? If it does, then that would be pretty worrying, because it's like producing like, it's drawing from a set of possible jailbreaks rather than finding like, and that could be like pretty different strategies. So those kinds of approaches I think are like most worrying, because that would kind of be the hardest to patch with just retraining your classifier, unless you like rediscover the same approach basically. Yep.
I have a question about how you recognize that there's been a new jailbreak, and why not just use that as your, if you have some system for recognizing that there's been a new jailbreak, why not use that as your output classifier? And then the same question in a slightly different variant is when there was the competition for trying to find new jailbreaks. What was the difference between the output classifier and the thing that checked whether someone had successfully jailbroken the level, and why weren't they the same system?
Yeah, so, I guess one thing, for the first question, you could use potentially a lot more test time compute if you're doing the monitoring offline. I think you want to like, for online monitoring, you want generally just like low latency, and like it's very annoying if you don't have low latency or even like variable latency, and so like it's just helpful from a customer experience standpoint to just like serve the response like as quickly as you can basically, and then like after the fact use like I can like one example system you could use for offline monitoring is like you check the score from your online monitor, which is like doing this token by token classification. If that score is above some like pretty liberal threshold, like you take the top 20% most worrying queries, you then run a bigger, instead of like Haiku 3.5, you run Sonnet 3.5 without chain of thought. If the query is flagged at the top 20 percentile of those queries, then you give it to a Sonnet 3.7 with like lots of thinking and like best event sampling or some like very complicated thing that then flags, and then you take the top 20% of those, give it to a human to manually review. That whole process could take like a few hours to like lead to the label getting checked. And so like that's one process that like would be challenging to run like online. For the second thing, the way we evaluated if the person elicited enough information, I mean, maybe I should just go to that, is we have these kind of like rubrics where like we had a list of like 10 questions where we generated a lot of different, for that question, we generated a lot of different, it's like the kind of question which should be covered by the constitution of like harmful rules, of like things that should be blocked. And we then generated lots of different responses from model trained to not refuse. I think it was like a 3.5 Sonnet, like helpful only model. And then basically from those extracted like, here are some of the main things that are occurring, main like facts that are occurring in the response. And then from those we would basically like per question just like grade if, I think it was automatically just like grade if that rubric point was hit, like if the response contained that information. So we're kind of trying to say like basically if you have this guarded version of the system, how helpful are the responses relative to like a fully unguarded, no refusal training version of the system. This is something you can construct like for a particular question, but is, I guess you could also maybe do that for just like any question that comes in, but it just takes a lot more test time compute to do that, and so it's like more expensive, but yeah. Cool, yeah, maybe the last question.
So I was wondering a bit about the design of the classifier, like architecturally, because we kind of thought about this problem as well, and so I was wondering, is it like a smaller model? Is it like a final LLM that you're kind of changing? Because what kind of our thinking was that as you improve the model, its capability gets better as well, for instance. And so, the classifier isn't powerful enough to detect possible attack vectors, for instance. It's much more difficult to scale it with the capability model.
Yeah, I think that's right. That's definitely the case. I think here we basically were, we used a Haiku 3.5 based classifier to guard a Sonnet 3.5 model. We found that was sufficient for getting the level of robustness that we stated here. I definitely agree that this leaves like that capability gap between the classifier and the main text generation model leaves some gap that can be exploited, but in practice we found it wasn't like super obvious like how to exploit that such that we were still able to get the level of robustness here.
But isn't it also significantly more expensive because you now need to have 3 models in kind of memory, right? You need to have the input classifier, the actual model, the AI assistant, and the output classifier, rather than like getting the model to kind of say, for instance, monitor itself.
Yeah, I think that you could. I mean, basically, this is all like good future work. Like, I would be excited for people to come up with like merge strategies. I think there's certainly like different approaches. You could use like based on like probes, for example. And so like I think we have started to look somewhat into like whether probes or some fancier version of that could work. I think there's another approach from the Center for AI Safety and called short circuiting, which effectively is somewhat like can be viewed as like you train a classifier and the text generation model, but like into the same model. It's not exactly like that, but basically like that seems to work. I think the difficulty with that is like your classifier is no longer decoupled with your policy, and so like if you're training like kind of like a joint policy and value head at the same time, but now you realize like, oh, there's a new jailbreak, I want to update the value model or your like classifier, then like now that also influences your text generation policy, and that can have like, then now you worry about like if you update your policy, then that has regressions for like lots of different customers, and it's like a big headache to update basically. Cool, I'm gonna move on. So yeah, just quickly, I mean, this is what the streaming outputs look like. So we have these like per token classifications. If it hits above a certain threshold, then we like block the rest. We just stop generating. So there is like some risk where like the first n tokens that get generated could have been harmful, and so there's like some information that's leaking here. For the human red teaming, we got about 400 red teamers, including like professional and full-time red teamers, partnered with HackerOne, gave, as I said, these 10 questions, evaluated this rubric-based grading, and we would pay out we had a bounty, and we would pay out the bounty if over half of the rubric kind of like topics or facts were answered for all 10 questions with like a single strategy. So it doesn't have to be like a single prompt template or a single prompt that elicits all of the answers. It just has to be like a single strategy. Yeah.
Like you, in the streaming case, you are just streaming something and suddenly you say, I can't do that. This is a bad user experience. The classifier alone cannot do it. It's only binary signal, but how can we avoid bad user experiences like that?
I mean, I think that's where having a very good classifier just helps. Like, I think it's fine if it's a bad user experience, but like only in cases where the query is actually harmful. I think we maybe don't really care about user experiences in those cases. So I think if you have a sufficiently good classifier and like a high threshold or low false positive rate, then I think it's okay. Cool. So these results are on like earlier system with Sonnet 3.5 classifiers, but we have since like reduced them to Haiku 3.5 classifiers. This is just like the results I'll present are like an earlier version of the system. So here are the results from the red teaming. This was like we had two. I guess this was the private red teaming that we hosted where we like held signups. People could sign up and like do this HackerOne program. Separately, we later ran the public one where like the Anthropic Twitter account tweeted about this, and like people could just like pull up the chat interface. So like this is the earlier version. Here's the number of questions. So basically, people could submit reports when they think they found a successful jailbreak, and you can see like how much information relative to a helpful only model that they were getting for how many of the questions. And you can see like there were a few reports which got, say, like 8 or 9 for like at the like 50% level of detail, got 8 or 9 out of the 10 questions, and at the like full level of detail, only like 5 questions or so. Even for the ones where they were getting like 8 or 9 questions at like half the level of detail, like often the strategies are like somewhat degenerate and kind of like hacking the way that we were grading things, where, for example, they would ask like, I think they would ask like 50 questions, which were like paraphrases or like related to the original question. And so you get like a huge output, but like if you're actually trying to use the information from the output, like you have no idea what is correct or incorrect information in that output. You just got this like massive report, which is not like as useful as just like a single question answer response. So yeah, I think overall like this probably like overestimates, or like the naive read of this plot like overestimates what we think is the level of risk here. There's other things, which is like when we were running the red teaming, we gave some feedback to the red teamers because basically they were just like, this is too hard without any feedback on how we're doing, which is actually like a real part of the problem if you're trying to red team the system. So yeah, that's another thing. In terms of like the different questions are like different amounts of difficult to elicit answers to. So yeah, you can see like for this Q2, like there's nobody got a 100% detailed response to that, whereas for some other questions, like a lot of people did. And yeah, in terms of like by red teamer, you can see like different red teamers were like pretty differently effective at like getting different amounts of information from the models. Yeah, I might just try to speed through the talk and take some questions later. Yeah, in terms of false positive rate, we kind of got like pretty good false positive rate from Haiku 3.5 base classifier, like better than a prompted Sonnet 3.5 classifier. And yeah, in terms of like inference overhead, I think we were getting about like 24% inference overhead with this approach. So yeah, it's still like notable like decrease to your revenue if you're deploying this, but like if you're deploying a sufficiently like dangerous model, then like this is something you would want to use. But yeah, we also think that we can get that to be lower potentially. Yeah, like maybe like a simple thing to note is like if we can just stick with 3.5 Haiku based classifiers and we deploy an even more expensive model than 3.5 Sonnet, then like the relative overhead is already automatically going to be less. Yeah, and as I kind of mentioned, like this is kind of the general outline for like how we would make a safety case that our model is safe. We'd say like, well, we have these constitutional classifiers. They take thousands of hours to jailbreak in this universal way. We think we have good enough offline jailbreak detection. Hopefully, we have to develop some methods there. And then we also think we have like good ways of like rapidly updating the classifiers. We have a paper as well on doing rapid response, and like the general strategy there, which seems to work quite well, is as soon as you find a single jailbreak, you use a language model to proliferate that to find other examples of successful jailbreaks. You verify, like, for example, automatically that those are successful jailbreaks, and then just like retrain with all those proliferated jailbreaks your new classifier, and like that works really well. So yeah, like currently we are confident we can seriously impede language model-driven CBRN misuse risks from non-state actors. I think for actors that are more resourced, where they would be able to just pay out like really large amounts of red teamers, we're less confident that the system would be sufficient, or maybe that we would need to just like iterate on it a lot more. But yeah, I think that's currently where we're at. I think the other thing I want to highlight is like this work directly happened because of Anthropic's responsible scaling policy, where we have this policy which basically indicates if we hit this level of risk, like if models are able to help with bioweapon or chemical weapon development up to a certain level, then Anthropic will be like sufficiently robust to mitigate that risk. And so like that was a commitment that the company made, that we would not deploy models that were so capable until we had such mitigations in place. Our team read that commitment and we're like, this is like kind of terrifying. Like this is like a never before seen level of jailbreak robustness that like the company's asking for us, but it like kind of makes sense based on the situation. So yeah, we basically just like at the start of the project, we like read that line in the responsible scaling plan, and we're like, well, like we actually need to like hit, this is the level of robustness we need to hit for like this particular threat model on universal jailbreaks, and then we switched from like this kind of adversarial training approach we were looking at before to like this classifiers-based approach, which we thought could get there. So yeah, I guess it's like kind of a shout out to like pre-committing to like what level of safety you need, and then back-chaining like what research would be helpful to get that. So yeah, I mean, I think basically overall, I think, yeah, can we make language models safe even if we don't trust them? For jailbreak robustness, seems like, at least for some of the like CBRN risks that are coming online soon, we think probably yes. I'll kind of sprint through this a little bit, touch on like some work we've done for misalignment related risks for alignment faking. Maybe I'll just pause it.
Well, I mean,
all right, well, yeah, what's your question?
I can't apply that, but on the other hand, you could read the result of the public-facing thing as, you could read that in a rather negative way, as you're in fact not reading this or something, right? Where, I mean, you're sort of relying on some sort of economic factor rather than the technical factors that people use.
I mean, I think basically like with the, I mean, I actually don't think that we need to get perfect level of robustness to universal jailbreaks for mitigating this kind of like multi-step scientific process for developing a weapon threat model. Yeah, I mean, I think basically like my rough sense is that it probably takes like 100 plus queries to get over the course of like multiple weeks to get to be able to develop, if you're a non-expert, to be able to develop some of these weapons. And like basically I think there are just like other easier strategies than using a language model to get that information.
It's like one bug bounty. How do you know you actually reached the relevant kind of statistics?
So yeah, so to be clear, like when I'm saying currently confident, I just mean like we as a team, we are feeling at peace. We're feeling like we're on track for getting the level of robustness we need for in the time frame we would need it for when models will be sufficiently capable for bioweapons and also chemical weapons risk. We have not yet like officially confirmed that. We would like basically want to like actually deploy the system on like all of the models, like then maybe rerun another bug bounty program or just monitor what the situation is, then write up like a safety case being like, here's our full system, here's what we've observed with empirical evidence. And then like, so yeah, I think there's still like many like I's and T's to dot and cross. But in terms of like the general approach, like before we were like basically panicked that there was like no existing general approach for like getting to this level of robustness, and now we're not. Cool. So yeah, I guess in terms of, I'm just going to touch a little bit on like how does this apply to alignment risk. So let's say you're worried that your model has a different goal than what you trained it to have, like in the alignment faking case. How do these ideas of like control and monitoring apply there? Yeah, just I think basically the general approach is like, well, you want to list out what threat models you're worried about and then go and try to make a similar kind of safety case there, like kind of what we did for jailbreak robustness. I think the major use cases of AI are going to be either roughly categorized into like external deployment, like anything you would use outside of a lab with an API, or internal deployment. So this would be like Claude code used inside Anthropic to develop and run experiments, or like cursor agents, basically just for AI R&D. I won't like super defend this here, but like I think currently we think that a lot of the major risks are potentially going to come from this internal deployment category. Why is that? I think generally it could lead to AIs that are no longer under your control. Like if the AIs escape, like self-exfiltrate their weights, or if they deploy themselves internally and are like running on your internal cluster but without you knowing what they're doing, or they could sabotage your automated safety research, and maybe that leads to the developer deploying some kind of AI that they falsely think is safe. So yeah, I think at the point where there's kind of like an AI that's like out of your control, that I would say is like pretty irreversible if it's like sufficiently autonomous. So I think basically mitigating these internal risks is one of the big focus areas for like backstop to alignment. For self-exfiltration, you can maybe solve this with computer security. So maybe you say like, let's not let sufficient amount of data leave. You compute what's the amount of data you need to exfiltrate in order to exfiltrate the model weights, and you ensure you set security protocols such that you cannot exfiltrate that amount of data from your data center. And yeah, and maybe this like makes it so it's hard to like get videos out from your data center, but like that's also not a super necessary thing. And then maybe that's actually kind of sufficient for, it's TBD, but I think that could be sufficient for mitigating this risk. There's some other risks, like maybe the model kind of like removes some safeguards for its internal usage. So yeah, just quickly getting into this, we had this blog post on a toy evaluation for inference code tampering, where the setup is like maybe there's a coding agent that removes some key safety mitigation for its internal use, like monitoring its chain of thought reasoning for any dangerous reasoning. And maybe it does this while it's doing other useful tasks, like improving your inference code to make it more efficient or make a better sampling algorithm or something like that. And yeah, the setup is basically we have some like simple generation code which the model needs to modify in order to like basically make this oversight call something that's like not always called, so that some of the samples of which involve chain of thought reasoning are like no longer monitored, and now the model can do like bad reasoning about bad goals without worrying about it getting caught. Yeah, I think basically the TLDR is like the models currently can introduce successful attacks when they don't need to look unsuspicious. They can implement strategies included in a few-shot prompt, so they can replicate existing strategies in a way that gets around a monitor that's checking for if the model has done this subversion. But the models currently can't come up with new strategies that are not included in the prompt, which also successfully get around a monitor. So yeah, overall, basically, we think Claude is like not able to come up with new strategies for subverting a monitor, and we think that means the risk here is relatively low. This is like an example of the kind of evaluation you would want to run for misalignment. Obviously, you want to do like a way more thorough version of this, like what we did for jailbreak robustness, but kind of gives you a taste of like how we would apply these ideas to controlling AI systems. And you can also do similar things for sabotaging automated safety research. So here we had another blog post which exemplifies some of the ideas here. I would encourage you to read that if you're interested. But basically, there's two kinds of risks you could study here. One is like maybe the model will make some of your experiments incorrect. So maybe it like runs them incorrectly so that you think some safety research idea is less promising than it could be. In another case, it could steer you to running different experiments by like persuading you of like an incorrect experiment to run. In these two cases, you can do something similar where maybe basically the way we run this task is we have kind of like a task which is like code a classifier for doing like sentiment book classification, and then we have like a coding agent run around and like implement some script to do this, and then it can like plan for how to do that, and we can plan how to subtly sabotage the task without getting caught by another monitor. And yeah, basically like the TLDR here is like this is like starting to emerge as like something models can do in a way that they can not get caught while they like significantly hurt the quality of the experiments. And they can also and also they can do this to guide which experiments to run in a way where like the justification is not easily detected by another monitor that this is like a bad justification for like which experiment should get run. So yeah, I mean, overall, I think for human level coding agents, it looks like not out of the question to defend against these three threats. I think it's still TBD, and probably the hardest one we think right now is sabotaging automated safety research, in that that's where it's like currently hardest for us to automatically detect that this is happening. So yeah, I mean, overall, I think this is like my current state is like probably for jailbreak robustness, the monitors seem like quite a promising strategy, definitely much more promising than adversarial training. For misalignment, I think for some threats, it looks like we can block these pretty well with monitors, but for other threats like sabotaging safety research, it's much less clear, and we need a lot more work in order to make safety cases that way. So yeah, thanks a lot. Happy to take questions. Yes?
I'm wondering if there's analysis on the usefulness versus safety against jailbreak. for CBRN, but also including other use cases for the constitutional classifier. That's more borderline.
Yeah, I think we had, I forget what the exact stat is. I think we have somewhere the false positive rate relative increase. I actually forget the number, but oh yeah, I mean here, you can see like, yeah, this is no classifiers, and this is like with the Haiku 3.5 base classifier. So here it looks like the absolute increase in refusal rate is like 0.5%, I think, across Claude.ai traffic. I think since then the number is like much lower since we've kept improving, improving the results. But yeah, that's the rough sense of like what the increase is. Yeah.
Yeah. So my impression is that this generative model has many capabilities, the LLM itself. And then you have such capable model, and you're pairing that with a classifier, right? And if the generative model decides to fool the classifier, in the sense, it would just invent a new encoding, or a coding language where it would produce all the unsafe output it needs.
Yep.
But just shifts the character by one character. Just shifts by one character, and then how would the classifier catch? Because classifier is not that intelligent, right?
I think you can just train the classifier to block that. You can just be like, you should not be encoding, it should be intelligible English in your output. And that will increase the false positive rate some, because I guess in like some small number of cases it's useful to like do encoding, but that's just like a really weird particular use case. There's like other variations like that you can think of, but like basically in all those cases I'm just like, we can just block that. It increases false positive rate some, but generally it's like a pretty niche kind of risk.
Part of your training?
I think it might be, but I'm not positive. But yeah, I mean, in general, we are robust to this kind of like cipher type encoding risk, and despite the fact that we only use output classifiers, and I think that might be like one of the reasons why. But yeah, I would need to check. Yeah.
I want to get your thoughts on constitutional classifiers as a research paradigm. So, I mean, we know that we will have open weights models which won't be too far behind what OpenAI and Anthropic has, right? So then, like, such a system won't be applicable to them in terms of mitigating safety risks, right? So what do we do then?
Yeah, so I think the way I see it is basically we want, oftentimes I think the highest risk period of time for a new capability model to be deployed is just the first few months. And so if we can have very good safeguards for deploying a new capability level model before there are open weights models released, then that lets us mitigate the risks in the new time period. And then we can also observe the traffic and see, like, are people actually trying to do like weapons of mass destruction development with these models? If so, and if it seems like, you know, depending on how successful they look like they are, then we can like write a report being like, this is what's happening, and like provide actually a lot more evidence than there currently is that it is actually dangerous to release open weight models. Yeah, and same for misalignment risk as well. Like, I think we want to like catch the, you know, misalignment's most likely to arise for the most capable models. We want to catch that early before it happens. Then we can like write up a very detailed report with lots of compelling evidence about that. The other thing I would say is, like, before, I think the case against open weight model releases was like just way weaker if you can just easily jailbreak a black box system. I think now that we have a technical approach which can get a significant like level of improvement over like open weight models, I think it's like makes the discussion in policy circles like much clearer what the situation is. It's like, well, actually now there is a clear value add to not releasing open weight models of a certain capability level. Like, it's unclear when we like / if we should stop that at some point. But I think before it was just like, in my mind, there's like no justification to not open weight the models, are like very limited.
And then one more question.
Cool. Yeah.
So just on the point of like the subtle sabotaging of like the internal AI safety research, like I'm wondering, like in this case, like the model is effectively prompted to be sneaky in a certain way, right? To like do a sort of deceptive reasoning and to then modify the model. So what is like the, I guess, real world case where this would occur? Like, is this like this is for like internal use for research? Like, is there like an external attacker who's like intercepting the prompt somehow and injecting code instructing the model to be deceptive? Or like what, I guess?
Yeah, I mean, I think the threat model here is that the model is itself emergently misaligned, but maybe that we can't tell that it is.
But in this case, it's prompted to...
Yeah, so what we're doing here is basically we're like, let's simulate that by just like not making any assumptions about whether or not the model is aligned. We're going to actually like directly try to like maximally elicit its capabilities of doing this subtle sabotage. And the hope is that like, you know, in the ideal case, you fine tune or you RL it to be extremely good at this kind of subtle sabotage. And then you see like, is that still possible for us to catch in all cases? If so, even in the event that this model were emergently misaligned, like it would not have the capabilities to subvert our monitoring mechanism.
The fear that it'll spontaneously become like sabotaging, I guess, or like...
Yeah, that's right. Yeah, and this is basically like a capability eval for like, suppose we made no assumptions on alignment, would it even be capable of circumventing our monitoring or security mitigations? Cool. Thanks a lot.